Willkommen. That's German, so welcome. Welcome to the session. My name is Oliver. I'm supported by Jacob, and Bethany is...
She's close.
She's close to us. Ah!
Hello,
Bethany! AKA the Queen of Awesomeness and Mathemagics. So, and actually, Jacob is just the traditional Bavarian, hyper. We will talk today about the data source pane or data source gain. And actually, before we start, there are some related sessions because we are talking about the foundation of how to get data into Tableau. And there are some sessions that are really related to it. So the fast and the curious, if you want to learn more about how to get data into accelerating a dashboard, also optimizing the data sources for an enterprise data strategy, and there are some more. So most of them, they haven't been conducted yet. So if you would like to know more about data source and how to leverage the data source pane in Tableau, so you are free to get to them. So what's actually in for you? So the data source pane, when you are just a data analyst, you're just throwing the data in and you're starting analyzing, right? But it's more important to stay a little bit longer in that pane, and we will talk about that later, how that works and what you should think about. Because when we introduce Tableau Server or Data Server in Tableau Server in the version 7, more and more people are using published data sources. And before that, you got in trouble maybe only on your own when you didn't think about how can we leverage extracting and these kind of things. But now you maybe as an analyst, you are providing data sources to a wider audience. And then most of the people get in trouble because you spent not that much time in the data source pane. So what we try to do today, and I'm happy to host this session, is to make you feel more confident in that session and feel better if you are using the data source pane. How do we do this? Actually, we are talking about the live connection and the extracts because, I mean, we heard in a keynote session that Tableau is providing the most flexible system or BI platform in the world, but with flexibility, it comes always a choice. Right? You have to choose wisely which way to go to have the best outcome. Also, we will talk about join culling and custom SQL. And after that, Jacob will talk about the hyper extraction. So once again, hyper. And after that, Bethany will talk about the upcoming golden age of modeling. So the data pane, what is that actually? So if you already use Tableau Desktop, you have to go through the data pane before you start analyzing the data. And it looks actually like this. So who is familiar with that view? Hopefully everybody who is working with Tableau Desktop. OK, almost everybody. So on the left-hand side, once you connect it to your data source, and it doesn't matter what kind of data source it is, you got provided all the fields, either it's table or it's views, and even you can put custom SQL. We'll cover that later. And while dragging over, you can build your model. On the bottom, you can see what kind of data you are connecting to. Is it the right one if you have multiple data or whatever, and also can create some calculations and manipulations to the data. And also you can switch between the raw data view and also the metadata view, where you can see that field comes from that table and so on. On the third part, it's actually the model you are getting, you are modeling. And I can only recommend that dataset if you are bored. Just go and download the Lego database. It's really the best model I've ever heard of, and I used it. Right? So I'm a data nerd, I'm a Lego nerd, and I'm a football nerd. So in this case, you are building up your model, but then right away you have to choose either you go live or you can extract the data. What was the difference? When to use what? And actually, always you have to think about what's better. And while it's easy to say which one of these are better, it's not easy to tell or easy to say go live or extract. Well, it depends, right? When does it make sense to go live? If you have, well, a fast database. Who already have a fast database? Very good, lucky you. Right? If you would like to reuse already security built in your data source, if you are extracting the data, you cannot reuse the security, right? Because you're extracting the data, you have to rebuild the security model in the extract. Even if you have near real-time data updates, it doesn't make sense to extract once again that data, right? Because you have a pipeline of data, just keep that in your fast database, and then with every query you're taking or you are sending against the database, you have the updated data. Reasons for life, actually, leverage your investment in your infrastructure. If you already have invested in SAP HANA or in Exasol or in Vertica, Teradata, which is actually not really cheap, then you can leverage that investment to go live. And also, that my motto, and also for Tableau, and it should also yours, keep the data as where it is as much as possible, right? Data replication doesn't make sense. When it makes sense, using an extract. Well, if you have no database or a slow database in place, right? Or if you are using, for example, Tableau Prep, then you're already creating an extract afterwards as an output. Also, if you have, for example, periodical reports, like monthly reports, quarterly reports, weekly reports, it doesn't make sense always to create queries against the database. Just extract the portion of the data which you would like to provide to the end user, and then get rid of all the workload of the database or in the database. Also, prototyping, offline analysis, if you're going on a journey, just grab the data, and then you can go and analyze further. And there's one big point next to it, and it comes with a commercial perspective. You can reduce costs if you're using AWS or Google Cloud, and you have to pay per query. So once you're just extracting the data, it's just one query, and you have the data in Tableau, and it doesn't matter how many queries you send against the extract, you save money, right? So also a reason for extracts, well, accelerate also your dashboard and analysis. But if you are doing this, please reduce the number of information in the extract. It doesn't make sense to extract your whole terabyte data into the engine of Tableau, right? How do you do this? Well, the extract engine has some features which is called aggregate rows for visual dimensions. So you are reducing the number of rows, or even if you are hiding columns from the initial view, then Tableau is not querying these columns, and it's not stored in the extract. There's one concept within Tableau which makes dashboards really fast. It is called joint culling. And before I talk about that in theory, I will show you it in a live demo. And I will use Tableau Desktop and the Tableau Log Viewer. Who knows the Tableau Log Viewer? OK, not that much. Tableau Log Viewer is available without any charge on GitHub. As you can see, there's the link. And it shows you, actually, the content of the logs within Tableau Desktop. You can see currently on the left-hand side, there's Tableau. And on the right, there's the Tableau Log Viewer. And how do we get to our data? So we go to the Data Source Pane. We see on the left-hand side, once we are connected to the data source, our tables and wire dragging and dropping. So most of you know this, how we can create our models and so on. I already created my content here. And as you can see, on the right-hand side, there's the Tableau log viewer. So once you download the Tableau log viewer and you are installed it, you open up, you go to your Tableau repository onto logs, and there's a log.txt. It shows you everything what Tableau is doing in the background. We can go to clear events, go to live mode, and once I'm clicking here, you can see what happens in the background, so it's quite much. What we are searching for is now the QP batch summary. Why? Because this element here shows what's going on in the background. I would like to highlight all elements of that type, and I go to highlight mode, and once again I clear the event. If I now hit the F5 button, you can see there's one element, and I click on it and I can see what Tableau was generating in the background against the database. As you can see, I just drag over the number of pieces which actually is stored in the fact table. Tableau is creating all the inner joins. So it's really expensive, right? Because the data source has always to join the data, although I just grab one field from the fact table. So how can we get rid of it? Tableau has this concept of assume referential integrity. That means it doesn't matter if you have all the joins in the SQL statement or just grabbing the information from that one table, it won't change. If I hit that button here and go back and I hit F5 once again, first of all, you can see that the runtime is much less. If I go back into the SQL, and there is no inner join in there. Imagine, so currently, yes, it's both under 1 second, but it's just one query, it's just one worksheet. Imagine you have queries, multiple worksheets on a dashboard, then that difference matters. Let's go back to the presentation. So what did we see? We saw our model, and if you have the possibility to configure your referential integrity in your database, please do this, right? If assume referential integrity makes sense, that means if you can be sure that if we querying just one fact table or comparing to the whole model, the number won't change, then do this. It just impacts, well, because we are cutting joins, it doesn't affect on a single table, right? Because we are just querying a single table. And by the way, if you have filters on the dimension, it always takes advantage of the join cutting, so we are just querying that single table to get rid of all the joins. Imagine once again, the question was, how many pieces do exist across my whole data set? If we have referential integrity disabled, and this is the default within Tableau, then the whole model get executed against the database, and we have the longer runtime. If you enable the referential integrity, we get rid of all the joins because they are not necessary, and then we have a runtime compare half a second to just 1/10 of a second, right? It's 5 times faster. Okay, custom SQL. Who is using custom SQL in Tableau? Oh my God. Okay. You are doing this, right? Why do I say this? So actually, once again, just a small demo because, before we are talking about it in theory. Also, once again, Tableau desktop and log viewer. And how do we get a custom SQL in there? Well, it's quite simple. Just convert to SQL, and you can see the whole SQL gets customized. And I said, OK. So now we have one element here. And if you have one big element, you cannot say assume referential integrity. right? Because we have just one object. What happens in the background? If we once again hit F5, we see almost the same number when we had the full join, because we have the full join, right? So Tableau wraps just the custom SQL into an inner SQL and then chooses the right information from the custom SQL. If you have this kind of custom SQL, well, there's custom SQLs in general, they are not evil. But as you can see, Tableau is not able to automatically cut the joins and just reference the columns they need. You could do something like this. So take a little bit of time, right? Some moments, analyze your custom SQL, and then you can also say, I would like to join multiple custom SQLs together, because then we can, once again, use the assume referential integrity. And Tableau is then able, let's do this once again. Where's oh, wrong. Now you can see, even if we have a custom SQL, we can leverage the resume referential integrity. So we can cut the join information. Let's go back to custom SQL. So in summary, why should you think about custom SQL? It's so easy, right? It's so comfortable. I do already have my my custom SQL. I put that in Tableau, and everything is good. Well, you should think about, because Tableau is not a data visualization tool, it's really a visual analytics tool. So if you are coming from classic BI, it was quite common to write your custom SQL code, put that in there, and it was then ready for web, right? Tableau works different, because it's just wrapping up the custom SQL, and either you are using it or not, it's executing the joins, the expensive calculation, and so on, and it's not that fast. There are some alternatives. So if you have a custom SQL and you have the possibility, use that as a foundation for a view in database, right? Or if you have stored procedures or custom common table expressions, then please use the initial SQL, because if you are using the initial SQL, it runs only once, right? And then you can access the temporary table, and the whole stored procedure and the CTE is not run every time. Yeah. So my advice: avoid custom SQL and stored procedures wherever you can. On the other hand, custom SQL in Tableau, really trust Tableau to do its job. Try to model the custom SQL in Tableau natively. As we saw, we can leverage resume referential integrity. We can leverage much more things than using in custom SQL. As we said, if you can, deconstruct monolithic custom SQLs. If you have to use custom SQLs, there's one way to filter it more in the inner SQL using parameter. And even with the new version of Tableau and the parameter actions, you can even have it dynamically. So there's one use case when you can use custom SQL because you only run them once, and it's to extract the data or to materialize the data in an extract. So, Jacob, please talk about extracts.
Thanks, Oliver.
Thanks.
Is it on?
Weiß nicht.
I hope so. Can you hear me?
No?
Cool. So yeah, the following part will be about Hyper, as I am from the Hyper team. And some of you might think, okay, what is Hyper and what will this be about? Well, one thing that Hyper also is a 90s trash party in Munich, where our office is located, but this will not be about this. Instead, it will be about those guys. This is the Hyper team, and about the database technology that those guys develop. And the Hyper database technology is used in different places within our products. It's used within prep. It's used if you do multi cross-database joins. But maybe most well-known it is the data engine behind extracts, right? And in the next 10 minutes, I want to give you 2 performance knobs that you might consider when you're using extracts to get the best performance out of your extracts. One of those 2 are multi-table storage for extracts, or just call them multi-table extracts. Who have heard about this feature? Okay, cool. So this is a new feature that we introduced in Tableau 2018.3, and it lets you basically choose when you create an extract to whether you want to have a single table extract or a multiple table extract. What is this? This basically changes how the extract data is stored at the physical storage level behind the scenes, right? And what we usually do, or what we've done in the past, is that we had, let's say, a remote data source, a remote database that has 3 tables that are joined together. And when you create an extract, what we do is during the time of creating this extract or refreshing this extract, we will just create one big table and perform all those joins during this time. But the new option that we have here is that you can create multiple table extracts. Hopefully. Oh yeah, there you go. So what it means is that if you have the same data source where you have 3 tables that are joined together, this will now result in an extract which is also those 3 tables stored individually. So they are not joined anymore during this extract creation or extract refresh time. But instead, if you open your viz, if you do some analysis, stuff like that, if you drag something around, the joins will then be performed during this query execution time. Right, so what does this mean? What is better? The thing is, I think that's kind of the common theme here, is that it really depends on the situation. Multiple tables are good obviously, if you have at least one join, otherwise there's no point in using them. And if it really, that's a very rough outline, but if it really takes forever or very long to create the extract, right? A couple of cases that we saw customers run into is, for instance, the situation that you want to have row-level security, where you have a fact table on the one hand, and an entitlement table on the other hand, which has the user and the kind of what the user can see. And then you, during the extract creation, you join those 2, and which in many cases results in just an extract which takes too long to create, or in some cases it's just too huge that it runs into timeouts, everything, it doesn't work. For those kind of scenarios, you should really try out if multiple table can help you here. The other thing that we have is, if you have huge wide data, or wide table on the one hand, like if you're using geospatial data, which there might be columns which are 100 kilobytes each, and you have a long table with many rows, if you join those together during the extract creation time, you will most likely run into similar problems. So again, this is a scenario where we really encourage to use the multiple table extracts. Yet, it's nothing that you should just use blindly. Why? Because workbooks might become slower when you use multiple table extracts if it takes too long to compute the join during runtime. So if the join itself is very expensive, multiple table extracts might be the reason here. In that case, you can anytime switch between those 2, and we recommend to use single tables then. The other thing is also that you cannot have certain capabilities for your extracts if you have multiple table extracts. For instance, you have to, or you must really use single table extracts if you're using incremental refreshes. If you're using if you use sampling or top-end filter, if you're doing joins other than equality joins, so if you're joining spatial data, an intersect join, this is something that is not supported for multiple table storage. Or if you have pass-through functions such as raw SQL. In that case, you have to stick to single table extracts. So this is the one knob that I want to tell you about. And the other one is about the Compute Calculations Now button. Who knows what this feature does? I expected this answer because I think that we did a very good job on really hiding it as much as possible, and I don't know why. But what you have to do is you have to go you have to right-click on the extract icon on your data source, and then you have to go to the extract submenu and then select the compute calculations now button. So I think most customers I talk to don't know that this thing even exists, right? So I think if you take one thing away, that there is a button to do this, I think I did a good job here. But what does it do when you actually press it? Well, basically it materializes the calculated fields. So that means that during the extract creation time or refresh time, or after you press this button, it will compute the results of your calculated fields and will take those results and store them physically, materialize them within the extract file. So what this means is that the performance characteristics of this thing really change. When you now load this, you can reduce the CPU load because you don't need to recompute those calculated fields, but you take the results, right? On the other hand, because you store something more, the file size of your extract will, of course, increase, and you have another step during the extract creation or refresh process, so those times will also be longer. It doesn't do everything. It's unable, for instance, to materialize volatile functions. Those are functions like now, today, that like return the current point in time. This cannot be calculated ahead of time. So if you have calculated fields that contain those kinds of functions, the whole field will not be materialized, and you shouldn't wonder why nothing changes if you have those functions. The other thing is that if you're using published data sources, and say those published data sources have a couple of calculated fields, and you're using those within a workbook where you add more calculated fields. When you press the materialize button, it will only materialize those that are defined as part of the published data source. It will not work for those additional calculated fields that you have in the workbook. If you want to make sure to materialize those, the only option to go is to embed the extract as part of this workbook. Right. And unfortunately, I think that's also a few feature requests is it doesn't do laundry yet. So this sounds like something, okay, finally we have an easy thing to do, right? Just materialize everything we got. And if you don't care for the file size, maybe for the increase in the file size, and if it takes a bit longer to create the extract, even then you would say, perfect, just materialize everything. This, however, is not true. The thing is, if you materialize stuff, some of it gets faster, but also about half of the workbooks that we run it on an internal test set, they got slower. And this might sound in the first, like the load times to see them, right, to view this. So this might sound a bit unintuitive first because you basically save CPU time. But the thing is, if you increase the file size and materialize the results, loading them from the disk into the memory, into CPU registers, sometimes it's just more expensive than having the CPU just calculated based on another value, the original column where this data comes from. So it really depends whether you're CPU bound or if you're IO bound. And I want to give you some insights or general advice when it's really a good idea to compute calculations now and when it's not. So for the do part, okay, when does it make sense to materialize calculations? The first thing is that if you're using lots of expensive functions, like string functions such as contains, find, lower. Now, I don't want to make you think about, if you design a dashboard, about, oh, how expensive is this calculated field I do. In those cases, mostly, forget about it. That's not what I'm talking about. If you're having a string parser where you do some kind of natural language analysis where you're looking for 20 strings in a very huge text blob and have different cases for those, you will know that if you've written a calculation that is really, really, really expensive, that's the case to think about this button. The other thing is, if you have a calculation that basically has a lot of cases, like if you do a case statement or if you do logical chains of and ors, that's the thing. If you got many of those conditions, this is also a good candidate to consider to materialize. And finally, what we found is that if you're concatenating multiple columns and use an operation on this one, and do not use the individual columns itself, this is something that's also provided huge benefits for the workbooks we tested with. On the other hand, don't materialize if you're using cheap calculations. And by cheap calculations, I mean arithmetics, but not only arithmetics. Basically, everything where you don't have the feeling I made something really, 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 really computation expensive, don't materialize. Another thing is, if you have, let's say you have one column, and you define, let's say, a couple, 5, 10, 20 calculated fields based on this one column. This is also an indicator where you should materialize, because what you do is you lose the dependency of the original column, and you replicate a lot of information for each calculated field. Whereas if you would have taken the route to not materialize, you would just load the one column into memory and do the computation on those, instead of having to load now, let's say, 5, 10, 20 times the data into your memory. And finally, what I said multiple times is, if extract size is of a problem for you, or if you're concerned about the time it takes to create or refresh an extract, this is also a good candidate for not to materialize, because we will see those kinds of effects. Okay, I think the bottom line here is, if you're not sure what to do, just don't materialize. If you now, after this session, you know, okay, I have this 1-2 dashboard with this very expensive calculations. I've done a lot of the stuff that's on the left side, and you have run into performance issues, consider materializing your results, and yeah, try it out. Okay, I hope that was helpful. That was the fun hyper part, as I would put it. But now comes the Bethany with the golden age of modeling, which is a very good title to create expectations.
Thank you so much, Jacob. It's been so long. So good to be back. All right, so I'm a product manager working on the new data model capabilities. Who's heard of Tableau's new data model? Few people. All right, you will all know very shortly what this is. So I'm going to start by just explaining how it's different to multi-table extracts, which you've just heard about from Jacob. So multi-table extracts are all about the actual storage of the data. So we've made it possible to store data in multiple tables, but we still treat them as a single table when we query multi-table extracts. So the new data model is going to leverage the multi-table extract technology in order to enable more flexible queries. And I'll show you what that means. But just to lay the kind of the reason why we're doing this and the goal. Ultimately, we are building technology to help defer decisions in the pipeline of data prep, data modeling, and data analysis. So sometimes today, you might be forced to do things in custom SQL or in data prep because of the structure of the data, when you'd actually rather the end user of your dashboard could decide that. They could apply a filter in a dashboard as opposed to in a data model. So that's the goal. And there are a few benefits to this. One is more flexible and dynamic analysis. Right? I can decide in a filter in a dashboard instead of in a custom SQL. Or I can decide to join tables in a worksheet instead of having to decide that upfront in the data model. And so when we enable more flexible and dynamic analysis, it means that we can support more users with fewer data sources and more questions. So for those of you who here creates published data sources for other people? A lot. OK, so instead of having to create 20 data sources, you should be able to create like 5 maybe. Some context actually on this original project. How it got funded was one of our engineers hacked a prototype and then rebuilt our internal customer 360 dashboard, which has 18 data sources behind it. And they rebuilt it in our new data model prototype in a single data source, and it was way faster. And then it got funded. And so that leads to point number 3 is better performance. So I'm going to show you this in the context of an example. So the scenario is I have 3 different tables of data, and they're at 3 different levels of granularity. So I have this region data. It gives me my geographic shapefiles. And then I have a population data source, and that tells me the population of every region by age group. And then I have my housing data set, which you've seen this morning. And that's specifically focused on London, while the other 2 data sources are for all of the UK. And that housing data source is at a transaction level. So every single house sale, there's a record. And then you can map that house to a region. So the relationship between these 3 tables is at the region level of detail. And so the goal is to, oh, I've lost my screens. What's happening? 1 second. Hold on. We're back up. All right. It's all good. No. I wasn't doing that. I just took it out of presentation mode. OK. So 3 different levels of granularity, different scope. My goal is to be able to combine these data sources, but not have to decide up front in the data model what questions my users can answer. So first, let me show you what happens when you join these 3 data sources in Tableau today. So if I drag out the population, so I've got population, regions, and house sales in here. So if I drag out population, this is the UK population. Look at that number. Hold on. Oh, I dragged out the wrong one. Sorry, that's the one where it's fixed. OK, if I drag out the population here. All right, it is 893 billion something. So the reason this is so inflated, this number, is because it's in a row-level join with the transaction table. It's copying the population of the region into the house transaction. And so when you sum that up, it ends up replicating that population value by the number of transactions that you have. So my measure is completely wrong. If I were then to look at transactions over time, so we've looked at the population data source, the measures there are not right. Let's see if the measures in the housing data source are right. So if I drag out in this one the, where was it? The date and the number of transactions. In this case here, it's saying that in some of these periods here, there were more than 15 million housing transactions in 1 year. Is that possible when the population of the City of London is only 8 million? It's not. So what's happening here is this number is also wrong, because in my population data source, it's broken down by age. And so by joining them, my transactions table is now being replicated by about 80, because there's a record from 0 to 80, and people live longer than that, 90, something like that. OK, so great. So in both my population table and my transactions table, my measures are wrong. And then let's look at not just measures, but also dimensions. And is Tableau doing reasonable things with dimensions? So I have this other data source on the boroughs. And so let me bring this out here and go and make a map, and then add in my population. Well, so now the numbers are going to be wrong. We've already seen the numbers that are wrong. But what I'm showing you here is that I've lost the rest of the UK. My original population data source was for the whole UK. But because I've joined it to this housing data source for London, I've lost the rest of that context. So in these 3 very basic cases, I'm not getting the right data. I'm not getting the right results. So let's see what happens if we connect to these tables using Tableau's new data model. So the key difference between the legacy, what we're calling the legacy data model, and the new data model is that we are relating tables as opposed to joining them. So let me show you what that means. So you'll notice here we have this brand new interface. So each one of these is an object. You'll notice as I'm clicking on each one of these, the data source grid is updating because each one of those is being treated as a separate table. We're not joining them into a single flat table because these things can't reasonably be represented in a single flat table. And so the way that these relationships are defined here is through this new relationship editor. And so one of the key differences between joins and relationships is that joins happen in every single query all the time. Whenever you drag anything from a data model, if you've joined tables, all of those joins will happen every single time. Whereas with relationships, we can issue much more nuanced contextual queries where we decide what pieces do we need. And if a visualization is only querying fields from a single object, then we won't join anything. And so that helps with performance. It also means you can have more relevant domains. And it also means that and the other thing we do with relationships is automatically aggregate measures to the level of detail that of the object they belong to. So let's go look at this population metric, or building this population map in this new world built on relationships. So if I grab my geometry, the local authority, and the population, let's go make this map. And now I'm seeing all of the UK. So I've defined exactly the same links as I did with the join, and it still belongs to a data source that has all the housing data, but in this worksheet, we're ignoring the housing sales in building this visualization. So that allows me to keep all of the data in the UK. And then if we look at the numbers just to check, is it giving the right thing? Let me make this really big so that you can see. So if I drag out the population here, you'll see that it's giving something very much within reason for the population you would expect from the UK. And then you'll also see that I have the age within this data source, so I have a more granular level of detail than the region, which is what's being used to relate to houses, to the house sales. So this is what you would call a you might call this a multi-fact data model, because there's a many-to-many relationship between the population data and the housing data. And so now let's go look at what happens with the transactions, the house transactions. So before it was double counting, but now if I grab I'm going to do a count, not a count distinct, but I'll change it over here. This is an alpha build. Sometimes it doesn't always, one sec. Let me go back to before. This is an alpha build that you can enroll in as well to help us find these bugs. I'll make this a count. So I'm going to do a count of transactions and then break that down by date. And now we're seeing numbers that are reasonable. This makes sense that you could have 95,000 transactions in a year, no longer the 15 million that we were seeing before. And I'm not doing a count distinct to get that. So another point here is if you go to any of the performance sessions, you'll hear that count distinct is an expensive operation because it has to deduplicate the transaction ID and then sort and do all kinds of expensive computation. Now, because this is because this is represented in a separate table, I can just do a count instead of a count distinct. And so even from that, we get a lot more improvements in performance. So we've looked at how, what was I going to do? Transactions by borough. And then, oh yes, and then the next one I wanted to show you is what happens now if I look at the transactions by borough on a map. So we looked at population by borough. That's working on this data source. It wasn't working on the joined one, but it's been kind of rectified with the relationships. So let's see if looking on the map at the house sales has improved. And so now what's happening is I only have housing data for London, but my region data is for all of the UK. So I have all this extra empty space that this may be too much flexibility. I may not want that level of choice in seeing London in the context of an empty UK. And so then the question is, well, how can we have the infinite flexibility of relationships, but also sometimes enforce a join to happen when it's desirable? And good news. The new data model supports both joins and relationships. So everything that you're used to today will continue with the new data model. We're only adding, we're not removing anything. So what I can do now, if I go into this data source tab here, let me show you what happens if we pop open one of these objects. So inside of this house sales object here, is the traditional join experience that you're used to today. And so here, I've joined my regions to my house sales, and I've done an inner join, and so that is going to filter out all of the regions where I don't have house sales. And so in this case, so these are, yeah, this is prep, this is modeling, is the way we're thinking about it. So the prep interface will generate a single table. The modeling interface, each object represents a how do I turn off notifications? Each object represents a, he's the founder of Empirical, the technology powering Explain the Mark, so hence the comment. Anyway, where was I? We're talking about objects. Yeah, each object is its own table. Inside that, you can define arbitrary complexity. So you can have joins, unions, custom SQL, all the things you're used to today. OK, so now let's look at what happens when we now connect to this hybrid model that has both joins and relationships in it. So if I go look at, so just a reminder, we were looking at this. This is not desirable. So what happens now in this new model where I still have population, I also have house sales, and I'm going to look now at the count of transactions by local authority. And I built it on the wrong data model. I tried to label my data sources with the color of the tab to avoid doing that. All right, so local authority, wait, hold on. Where is it? Geometry and local authority and transactions. Let's start with this. And then, here it is. Boom. There we go. So now I still have the infinite flexibility that I want, but I'm also able to constrain it in situations where filtering down is the desired behavior. So now let's look at the last scenario, which is, at the moment we've just looked at how you can build a data model where two things can coexist in the same model, but operate independently. The reason you would want to put them in the same data model is that so people have the option to combine them and calculate across them in arbitrary ways. So one thing you may want to do is, if we're looking at transactions over time so yeah, let's do transactions over time by local authority. We may want to find, like, where is there the highest number of transactions relative to the population that lives in that area. You would expect more populous areas to have more house sales. And so now I can create calculations across these different objects. So just easily dividing here by the population, which is at a different level of detail. So the scenario where people have instantly gone, oh, this is amazing, is in insurance. Are there anyone here from insurance? Few. OK, so policies and claims. If you need to calculate any kind of ratio across those things at different levels of detail, this is the solution for you. So that was just to give you a quick introduction to the data model. And now I would love if all of you would sign up to our new, there's my icon, to our new data model. So if you just search for Tableau data model, and you'll find it right here, tableau.com/data model. And so sign up here, and then you'll be enrolled in our alpha program. And yeah, we're on our 5th alpha right now, actively engaging, trying to get feedback. We want to know what you think of our interface, of our query semantics. Are we generating the SQL that you would want by default? All that kind of stuff. So if you want to have input into the most fundamental part of Tableau, this is a very good way. And also, you can just contact me directly as well if you want to follow up and have a conversation about your particular use case. So I think with that, we will bring you back up on stage and take some questions.
Thank you, Bethany. So now the mic is open for you. So if you have some questions.